Hello everyone and welcome to yet another math video. In this video I'm going to go over how to solve linear inequalities. So solving linear inequalities is very similar to solving linear equations. We just swap out the equal sign for one of the four symbols in the table above. There's one little twist I will mention along the way for linear only, and I'll mention it when it is needed. Okay, so in order to solve this inequality, for example 1, you will just perform all of the normal linear equation solving steps that you already know, except it is easiest when you keep the variable on the left side of the equation. Doing so will help you make sure you get the graph correct a little bit later on. And it looks like I'm going to run into this little, what did I say about it? Twist above here, that we get an answer that W is in fact greater than or equal to 7. Now you can probably tell that this inequality sign swapped directions, and that only happens when you multiply or divide by a negative in an inequality. So here's that little note for you. The direction changes when you multiply or divide by a negative. All right. So we have our answer. W is greater than or equal to 7, and this is what we call the inequality answer. We will use the inequality answer to make the set builder answer. And the way you make the set builder answer is to first, you just get to copy down the inequality answer for free. To the left of all of that, we will put a vertical bar, and then the variable that was used in the inequality, and we put some fancy curly braces around it. Now what this is telling you is that, hey, way back up here for this inequality, our answer is all of W as long as, that's what this vertical bar means, and then we put some conditions after it. And the only condition we have is that W needs to be greater than or equal to 7. Okay, so there's that. Up here in this little table, set builder inequality does in fact use the same symbols as inequality notation. From there, I would like to move over to the graph. Now you can see I have these little graphs down here already. Let me put some arrows on them to make them official. And in order to successfully graph this, all that should be required is that you take the number from the inequality you have here, in this case this 7, and we'll put it on the graph like this. From there, we need to shade, quote, shade, part of this graph. Now, we know that W is greater than 7, and having the variable on the left helps with the interpretation of that. So numbers like 8, 9, 10, maybe 700 million all work. They will all make this inequality true. What do all of those numbers have in common is that they are to the right of 7. So we know we will be shading over here to the right. Now the only other thing that needs to happen is we have to put some kind of symbol here telling us whether to include or exclude the value. Well, we can already see that we are in this include row up here because I see it's greater than or equal to, there it is, there it is. And so what that means is we will use a closed dot. That is a dot that's filled in. We can call this closed. And that's the kind of dot that goes on this graph. And we've completed the graph. Now the only other option we have for this in the table back at the top here is an open dot. So it's either closed or open. Closed means include, open means exclude. And we would use an open dot if we started with one of these inequalities here. Lastly, for the interval notation, in order to fully understand how to do that, I will put a negative infinity on the left side of this number line and a positive infinity on the right side of this number line. Now, interval notation only needs two values, a starting value and an ending value. And in math, you always start negative and end positive. And what do I mean by that? Well, we can start over here with the negative numbers, but that's not where we shaded the graph. So we keep going until our graph starts here at 7, and then it looks like it's shaded forever to the right. So the starting value here would be 7, and the ending value here is infinity. So we would go from 7 to infinity. Now we need grouping notation around this. And back at the table at the top here, we will use square brackets if an inequality or a graph tells you to include, and we will use parentheses if you were told to exclude. You additionally use parentheses for all infinities. You can think of it like this: if we are allowed to equal a number, then we can include that number in our answer. How are you supposed to include infinity? Another way of asking that question: how are you supposed to equal infinity? Infinity is unbounded. We can never equal infinity because it just keeps going. So we will always use parentheses around infinity. All right, now that I've done one example completely here, I will move through this next example relatively quickly. So the steps here to solve this one, it looks like some distribution needs to happen before we can do anything else. And from here, it looks like we can combine a couple things. Then we can get all of the x's in this inequality to the left side. Then we can add 6 to both sides to isolate the x term. Then we can divide both sides of this inequality by 10 and then simplify the resulting fraction to get x is less than 12 over 5. Now I'm going to stop here for a moment and say out loud that this inequality symbol did not change. And that is because you divide by a positive 10 here, like that. Okay, so to get from this inequality notation to set builder notation is pretty straightforward. Again, you can just write the inequality you got, 12 over 5, put a vertical bar to the left of it, put the variable we used to the left of that, and put it in curly braces. So we have the inequality, we have the set builder notation. I want to move to the graph next, so I will take the important number of 12 over 5. I'm going to, let's see here, look at this next, say that x is less than 12 over 5. And 12 over 5 is decimally equivalent to 2.4. So numbers like 2 and 1 and 0 and negative 100 million, all of those numbers have being to the left in common. Okay, from there we need to just consult our handy dandy chart. We have a less than symbol in both the inequality and set builder. That means we will use an open dot here. Cool. Let me put my negative infinity on the left side and positive infinity on the right. And this will help me find my interval notation. Remember, we need a starting point and an ending point. The starting point is always to the left of the ending point. And I can see that since this is where the graph is shaded, we're going to have a starting point of negative infinity and an ending point of 12 over 5. So negative infinity, comma, 12 over 5. Infinities from the table always get parentheses, and since there was an open dot with the number that we like here, it will also get a parenthesis. There we go. On to the next one. All right, new slide, new inequalities to solve. So again here, I see, for example 3, we need to find the solution set for the following inequality. We need to simplify both sides of the equation, first with these distributions. Then terms can be combined. It looks like we can combine 6x's with an x here, and a -6 and a -4. So what would that be? 7x's minus 10 is greater than or equal to 7x's minus 8. Y'all see what's going to happen here? Oh no. Get all the variables on the left side, so I'll subtract 7x's because that's what's on the right. All of this cancels out. -10 is greater than or equal to -8. Uh-oh. All right, what's going on here? Well, if all of the variables drop out of an inequality, it's sort of the same thing that happens when all of the variables drop out of a linear equation. We just have to look at this and determine whether or not it is true. -10 is greater than -8 is what I see here. And this is in fact false. And we can draw the same conclusion at this. If what you're looking at after all the variables drop out is false, that means there is no solution. So the no solution set builder is like this. Actually, is like this. There we go. That is called the empty set. The no solution for interval notation is this symbol. And oddly enough, no solution for a graph is just a blank number line. There's no number to put there, there's no dot, there's no direction to shade. It is literally just a blank number line. So you might be wondering, what happens if it's all real numbers then? If it's a true statement, say 4 is less than 17, that will tell you that you have a true inequality. So if everything is true, then here's how you write that. You can write down, the inequality, my fault, is something like this. There we go. The inequality would be all real numbers represented this way. The all real numbers for the interval notation you might remember as the double bar R. The all real numbers for set builder here would be whatever variable you're using. It's just a member of the real numbers like this for set builder. And then the graph, oddly enough, is a number line with another quote number line above it because it's shaded everywhere. So if you run into that, that's what that will look like. I want to move on to example 4. Example 4, we have another linear inequality with LCDs. Okay, so how do you find an LCD? Well, remember, start with the largest denominator. In this case, it's 12. And then you just do a quick check. Can I divide 12 by 12 evenly? Yeah. Can I divide 12 by 6 evenly? Yeah. Then you go through and you do the whole process of multiplying each term by the LCD and solving what you get after that. So this is what it looks like when you multiply by the LCD. The 12s in that last fraction cancel, thankfully. And when you do a 12 divided by 6 in that first fraction, it ends up being a 2. So this is what the rest of that next step looks like. From here, it just goes back to doing exactly what we did over here. We just have to make sure we distribute everything, combine like terms, so on and so on. That'll be 8x minus 6 plus 24 is greater than or equal to 2x minus 1. We can combine these together to get 8x plus 18 is greater than or equal to 2x minus 1. Do some quick maths here. Minus 2x minus 18 minus 18 to get the variables on the left and the numbers on the right. So 6x is greater than or equal to negative 19. And when you divide by 6, that tells you that x is greater than or equal to negative 19 over 6. That does not simplify, so that's just the answer. So we get the set builder notation for free. Remember, it's just that variable in a vertical bar to the left of the inequality, negative 19 over 6 with some curly braces around it. The graph at the bottom here is a number line with the important number. Remember, that is the negative 19 over 6. From the previous slide, because it is equal to, it will be a solid dot, and it'll shade to the right. So that's what the graph looks like. In order to get the interval notation, I'm going to put my infinities in here. Remember, interval notation starts with the most negative value and continues to the most positive value, aka left to right in this case. And you can see here where the graph is shaded, starts as far left as negative 19 over 6 and goes all the way to infinity. So 19 over 6 to infinity. Infinity always gets the curvy grouping symbol around it, whether it's positive or negative. And the negative 19 over 6, since the inequality and set builder notation both have equal to, that means this is a closed dot. That means this will be a square bracket. All right, and that is the last example for this video. Thanks for watching. See you in the next one.